We'll continue from partition, guys. Static partition we have seen. Dynamic partition will start today. So static partition, we had a limitation which was uh, not more data or file which we're receiving from industry or application or server is relatable with the static partition. Most of the time we'll have to apply this dynamic partitioning concept if you want to optimize our query, okay, based on the data set. So you will have to run this command first in order to enable dynamic partition, right? If you do not run this command, then dynamic partition will not be allowed, because by default this is in strict mode. You can check the mode just to using this command. We have seen that all. So today I'll directly start with this two command. I'll run this to enable dynamic partition and to enable the partition mode from strict to non-strict. We'll go to Cloudera cell, open terminal, and go to Hive cell. Okay, so databases. We'll go to that database which we have created for our practice, 12 p.m. and set that property, set hive dot exec exec dot dynamic dot partition dot mode. Currently this is strict. I'll change this to non-strict. Then we'll make this partition true also. Hive dot execution dynamic partition true. This is by default true, so no need to change this. If this is false, then you will have to make true. This is already there in my system. Now we'll create the table, and syntax is same as static partition. Okay, this is not different. And I'll try to create partition for the same table, which is transactional record. So tables, table description. So desk table name, or describe also you can write desk table name. And we have few columns: TXN number, transactional date, customer number, amount, category, product, city, state, span by. Now I want to make my partition based on the category. Okay, and why I'm using dynamic partition for this, because this category is not having just one category data. It has mixed information available. So static will not definitely work here, and that's why I'm creating the dynamic partition. Create table. We'll give this name as transactional records by category, txn recs by cat. Okay, you can define your column name. Is it config change for entire Hive queries or particular session? Particular session, Hatim. If you want to change for entire Hive, then there is a file hivesite.xml in the conf folder. So if you want to make any permanent changes on Hive cell, then you'll have to go there, user libhive /config, and there you will find hivesite.xml. So whatever changes, guys, I'm doing in this I'm running this set command. This is only active till the session is on. Once I exit from there, then the changes will revert back, and it went again. It will go to the previous by default value. Okay. Describe and table name I've given. I'll create the table. Create table txn rex by cat, and I want to partition this data based on the category. So txn number I'll give, which is integer. Txn date. I'm taking this column name from here. Txn date. Then txn date. Then sorry, this is string. Third column cost number, integer, amount is double. Category I want to make as a partition column, so I'll keep it last. Product. So after amount, I'm directly going to product. I'm skipping this because I will add this in the partitioned by syntax. Product is equal to string. City is also string. State, string. Spent by is also string. Before entering, verify it, but because if once you enter, then again you cannot come back to the first line. This is the problem in cell, okay, or limitation you can say. If you want to use the good editor option, you have Hue. You can go to Hue and run all this query. Same thing will work there also. Now create table name. All the column spelling is good, because if any column spelling is wrong, then I will not be able to insert data from that table to this table, and that's why I'm checking all the spelling. Yeah, all is good. Then partitioned by category, which is string. Now rest syntax, row format delimited, fields terminated by comma. Okay, fields terminated by comma, and that's it. Enter. Now I'll take the data from txn records and load here. Select, or we start actually from insert. Also I can start insert into. So two queries I will write, okay, one by one. You can check both. First query is insert into. Insert into will not use. Insert override table name. What is the target table? So this is my target table where I want to insert the data. txn rex by cat, and you want to take all this data from. So we'll have to specify partition here, okay? Partition, and we are doing partition on which column, that we need to write. Category, select, then a dot txn number, a dot txn date, a dot customer number. I can write a star also, but I will tell you why I'm not writing a star here. Because if I take a star, then it will start mapping this data one by one column. But that is not the case in my txn rex by cat, right? Can you map this? So if this is my table, in txn records by category, this table, my category is the last column. Whichever column you make as a partition, right? that goes to last. It does not store anywhere in between. This will be the last column of this table. So this is the last column, and I'm using here a star. I hope you know now how the star mapping is done. They'll map your TXN number with first, then TXN date with second, cust number with third, amount with fourth, and as soon as I reach to category, what will happen? This category data will store in amount product, which is the wrong data insertion. That's the reason I'm doing this a. Okay. Now after a dot cust number, a dot product, sorry, amount is there, a dot amount, a dot product, a dot city, a dot state, a dot spend by, the last a dot category. Distribute by from table, so from TXN records a distribute. I'll tell you what is the mean of this distribute by. We'll see total 5 reducer query. Okay, we'll differentiate between this distribute by, then group by, then sort by, order by, and there is one new reducer query, cluster by. So we'll separately take this all 5 differences. What is the difference between distribute by, sort by, order by, cluster by, group by? Group by, we already know this is, yesterday we have seen this. This is giving us result in key and value form. Sort by will by default sort your data in ascending order. If you want to give descending order, you can do that. So ascending and descending. Order by also does the same thing. There's one tiny difference between sort and order. Distribute and cluster we'll see this in a different example. So I'm not using distribute by now. This is one query which I can use. Or second query, I can start from here, from TXN records. I'll give alias for this, TXN, then insert overwrite. Okay, insert overwrite, table name, table name, partition, then partition column name, which is category. So I'm running this query. From TXN records, TXN, insert override table, table name, partition category. Then I'll take all this result and distribute by this data to category. So if I'm not using distribute by category, what will happen? We'll see after the query. Partition category, select a dot. Same thing I'm writing. TXN number, a dot TXN. Sorry, it should not be a this time. Alias is TXN. So TXN dot TXN number, TXN dot TXN date, TXN dot, just for more readability, I'm giving a space, TXN dot cust, TXN dot amount, TXN. You can check after amount. This is directly going to product. TXN dot product, TXN dot city, TXN dot state, TXN dot spend by, and TXN dot category. Just this and enter. So previous query will also work, this will also work. We'll wait for the output. Hatim, if you can precise your question, what do you mean by earlier created? You're talking about a static partition? Static partition, yeah. So static partition, syntax-wise, no change. Syntax-wise, there is no change. Only the property is strict and non-strict. That's the only change. Now, data looks like distributed and stored. Okay. So what is happening now here in the dynamic partition? If I type so partitions and table name txn rex by cat. Now, one thing I will tell you, yesterday, let me create one graph for static and dynamic so we can quickly relate and get the difference. In a static partition, again, this is only running, as the name suggests, static. This is only applicable where I have data. So currently I'm applying my partition on category column. So this category should have all the value with one name. One name as in there should be just one category. Let's say air sports is one category. So there should be n number of air sports only, not other data. Then we are using this static partition. Syntax wise for static and dynamic, there is no change. The way you create for static, the same way you're creating for dynamic also. But while loading the data in a static partition, you have two options. You can use load, and when you're loading this in your Hive cell and you pass a query that load data local in path file name into table name, you define externally or explicitly, you define that partition, this keyword you write, and then you'll have to write this value as an you're hard coding this value. You're hard coding this value if it is a static partition. You're writing here that this is taking this file is the file path which you're giving here is only keeping data which are related to air sports, right? That's one thing. Second, I can do insert from one table to second table, but again, while inserting this, I am defining this partition value. I'm writing it that category is equal to whatever the value I want to pass here. Then this query will only insert the matched information from category column. In this case, I'm doing this. Property wise, there is one change only. In Hive cell, this is by default set as strict mode. Okay, so strict mode means static partition, non-strict mode means dynamic partition. So you can make a note that when you're saying when you're seeing the property of dynamic partition as strict, which means there is a static partition, I will write with equal to the value which is strict. If it is dynamic partition, this is a non-strict. That's the only difference. But the best part for dynamic partition, load will not work here. You cannot directly load a file from local file system or from HDFS to your Hive table. This query, load query, will not work here. Okay, only insert will work, but I am not hard coding this value here. If you see my query, I gave partition column name partition and partition column name. I did not write that category is equal to some value, which I was doing yesterday for a static partition. So static is good for the data when you have all the data from one name only. Okay, you do not have unique information available in that. This is when you have mixed information available. So take some example, do some practice, then these things will be clear. Now, when I run this query, so partitions and table name, I can see this many records are partitioned without explicitly writing the category. Now, this result are stored in HDFS folder also. Can I go to HDFS and just verify this? I'll open one new terminal and type here HDFS dfs-ls, where the data goes by default, user high warehouse, since this is an internal table. User high warehouse and database name, which is 12pm.db, table name, txn rex by cat, enter. So this is the data which are separated based on the category. Only gymnastic related information I have in this folder. Only indoor games related information I have in this folder. Similarly, outdoor play equipment, puzzles, team sports, winter sports, etc. What is the benefit, by the way? One table I have which are non-partition table, right? So table, actually we should talk in numeric numbers. If we talk anything in math, things are more clear. So I'll use math here. txn rex by cat. I will run a query on this table, which is a non-partition table. So txn records is my non-partition table. It's like I just created the table and directly loaded all the data. This is the partition table. Okay. Can I run one same query on this txn records and on txn rex by cat and try to see the total time, execution time taken by the CPU or the system? I'll first run my query on non-partition table. And the query is as follows: select a star from table name txn records, where category is equal to air sports. So it's a string, that's why I'm keeping inside the single quote. Okay, and let me do some more granular. So first I will limit top 10 result and run for a query which is amount column, air sports, and let me keep just air sports, and for all the result. This is not TML, so time. If I want to check the time, I should run some DML operation. And let me run a DML. Select a star from txn records where category is air sports, or I'll say group by category. This is the aggregation query, group by category and some amount, where category is equal to air sports. think both we cannot use it. Where category is equal to, what's the problem? One second. Some spell mistake, I guess. Take some records. Expression not in group by key. From take some records. Group by category. Yeah, having will also take, and this should also work. So number of mapper 1, reducer 1. Okay. This is total. True. One is matching. This is because for Gary Sports, though they are taking for all the result. If I run the same query on the X, and I'll try with having ones, okay? Because this total time is included the execution of this all query. So I'm looking just for one option. Let me try other query, txm records. Group by category having here is sports. On the queries field, during job processing dates and date. Let me see there, okay. String cannot be cast to java.long.boolean. So it is failing because it is unable to produce true and false result. Okay, this is failing because of this. So having is working, task is processed also, but it is unable to convert the type. Anyway, let me check with some written example. I have some joining example here, so maybe I'll try there. But takes in rex by cat result can be much faster compared to takes in rex by cat, because balance you have converted to all the category values. Not you're running not running a query on table, you're running a query on file actually. If it is a partition table, you're running a query on file. I can have the solution of this, but for this I need to write a UDF, user defined functions. So using UDF we can handle this part. So we'll park this for a while. When we start UDF, we'll see this. After doing partitioning, there's an extra structure concept, and that extra structure concept we are getting from the concept called bucketing. Bucketing is using one core algorithm which are defined by hash functions. So hash function is one of the core algorithm, okay, which map your data, which index your data, and in Java collection, in Scala collection, in Python, we have all that hash function concept. I'll write what we call in other languages. In Hive, we call the same concept as bucketing. So this bucketing is using one algorithm, and we'll see that algorithm. What is that? What is this hash functions algorithm? Syntax for bucketing is clustered by. Syntax for bucketing is clustered by column name into how many buckets you want to divide your data. So partition was for structure, bucketing is for extra structure. Bucketing is for extra structure. I'll give an example first before going to any algorithm. What is the extra structure uh, data? How they're giving us the structure, new structure. Suppose I'm receiving data from United Nations. Okay, United Nations has given all the population data, all the census report, and they want to manage this in our database. They want to manage this in our database. According to UN, we have total 195 official countries. Okay, and by the way, I have collected this information from Wikipedia, number of countries. So I want to store all this population data, all this population data in my table, in some of the database, and I decided to store that in Hive. What I'm doing in Hive, I created first schema structure. What is the country ID? What's the person name? What's their maybe mobile number? What's their age? What's their gender? Okay, so many column, and store this data of all the 195 countries. So I have column person ID. There's one unique identification number of every person. Then we have their name, we have their age, we have their gender, then we have their uh, marital status, we have their country name or city name, then country name. This information is there with me, mail ID, phone number, etc. When you are doing partitioning, what is happening? Partition you're doing based on the country, let's say. So all 195 countries will store their data in a separate file. So in your HDFS, if this is the internal table, in your HDFS will create a separate file like this. When you run a command HDFS DFS -ls after creating the table and loading the data, when you check your user warehouse, user hive warehouse, user hive warehouse slash database name slash table name, which is world population is my table name, world pop, then slash country, and then I have, suppose I have distributed this in some column and I'm storing this data in ascending order. So we'll have data for Algeria, for Afghanistan, for uh, China, for India. So I'm writing two country name, Austria. Maybe Austria can comment the site if it is stored in a ascending order. Then USA, then France, then New Zealand. Okay, there are so many other countries. Total, how many countries? 195. So total 195 folder will be created like this. Now all the data is stored inside this. This is all related to Algeria. This is all related to Afghan. This is related to China, India, and so on. Now the question is here, total population of world, if you check according to world meter, that's 7.8 billion till date. And out of this number, every 5 people if we pick, that's from China, and every 7 people, this is what I'm talking about statistics, every 7 people if you pick, that's from India, because their population is so high. So out of other countries, these two countries having the large population, which means my partitioning only is not helping me to optimize my data. If I'm just doing partitioning, but still I have total 149 billion data here. Sorry, 1.49 billion data total in this. And here I have total 1.33 billion data total. So if this is the total data, then where I'm using the load transfer, right? Using partition, if you say in simple English, what exactly you're doing, you're transferring the load of your file so that when you run a query, that query should go to that specific folder and get the data. But currently in this case, we have so many population in these two countries. What shall I do for this? To handle this extra structure information, the concept of bucketing has been designed by Apache. They said you can provide extra structure to this data. Furthermore, say store your data based on the state or based on the union territories. So whatever number of states we have in China and whatever number of states we have in India, including union territories. So bucketing will provide me this information, which is giving me extra structure. Now, how to do that? What algorithm will create? So conceptually, you understand why I'll be using bucketing, not always fitting in the case. If it is required and fitting with my data, then only I will perform bucketing, not always. But partitioning is a major concept. Now question, Can you do bucketing after partitioning only? Or can you do just bucketing? So you can do just bucketing also. They're not related in any terms with each other. If I want to do bucketing, I can do the only bucketing. If I do partitioning, I can do only partitioning. If I want to combine, I can combine them. If I want to do two partitioning, one bucketing, I can do that. If I want to do one partitioning, two bucketing, I can play with that. I can do anything, no limitation is there that only one partition or one bucket or two partition or one bucket. So this is clear. Now we'll go to see the algorithm part. What algorithm? They have defined it using the concept of hash functions. And this universal concept is available in all the programming languages. Correct? The popular one in Java, this hash function concept is known as map, which transform your data in key value form. Here in Scala is a scalable language, very popular after 2010 and one of the great language today. This is also doing mapping because based on the collection concept, key value, and in Python, people who already have worked on Python, they must be knowing about dictionary. Dictionary is also based on key and value. I'm just relating this bucketing thing with other languages. Now let's go and see the algorithm part. What we'll be doing in bucketing. Bucketing works in this way. And bucketing is, by the way, good for joining. Okay, if you want to perform a joining operation between two tables, between multiple tables, so joining bucketing will increase the performance of joining. How they are increasing the performance of joining, that's a different part of discussion. First, algorithm. Algorithm is as follows: data, whatever data is present of any size. Okay, I will use here fx. I will tell you every part of math. Just be with me. Fx modulus. Suppose I want to define this whole data. Let's say there are total 500 data. 500 data points or 500 records. I want to divide this 500 records into three buckets. That bucket I can define. So I want to define this in divide in three buckets. Now I'll define their fx, which is my data. This is like integration and differentiation, right? A bit of math of 11th and 12th grade. Calculus. Fx modulus 3. Fx is my data, 3 is my bucket number. And this will divide the whole set of data in three buckets. Bucket number 1, bucket number 2, and bucket number 3. Now we'll take one example to divide in bucket. Suppose I have some data set as customer number. Okay, I have a data set, and by the way, I can perform this bucketing on a string column also and in integer column also, in float column also. So customer number is my column name, which is the type of integer, and I have some customer number here. I take a small number so that we can easily understand the math. I have here 7 as customer number, 10 as customer number, 11. I'm taking random values, okay, 15, 13. So if I'm storing in an incremental order, I'll keep the big number 17. Let me take 2 or 3 more. 19, 24, 3. 7 is enough to understand. So 7 is my total data in customer number column. And I want to apply bucketing on this column. Okay, so fx is my this total data. This fx is this total data. Now divide this number by 3. And before going to this, I don't know how many of you know the concept of modulus. So let me go to modulus first. A few questions ask if you're giving me right answer, then there's no part of discussion. 7 by 2 if I do, 19 by 5 if I do, and 99 by 100 if I do. Can you tell me the answer for this? What is the remainder here? Because this modulus tells me the remainder part. So what is the remainder for all these three? 1, 2, and 3. I'll wait for a minute if I receive any more. This is the math phase. Anyone? 1499. Okay. So one answer, which is right. Modulus works. This is the basic math. 7. So you take 7 as a numerator, right? But the upper side value is numerator. This is a denominator. I want to divide this by 2, and how many times this 7 can be divided by 2? That we'll see. So 2 can divide the 7 for 3 times, right? Because if I do 4 times, it is more than the number itself. So we'll have to go less than this. So 2 into 3 is giving me 6. 7 minus 6 is 1. And this is what we call as remainder. And this is what is a quotient. I'm not talking about the quotient. I am more interested to know the remainder part. Then similarly, if I do 19 by 5, 5 into 4 will be more, because 5 into 4 is 20. So 5 into 3, 15. 19 minus 15, 4. And this is again is my remainder. This is again my quotient. 99 by 100. So 100, this side, your denominator value is bigger than the numerator value. So obviously it cannot divide this any further. It cannot say 100 into 1. And in remainder, we are not looking data in float, in decimal. Remainder data will always come in integer form, in numeric form. Okay, remainder cannot be 0.52. Remember that. Remainder will be 1, 2, 3, 5, 7, 8, like that. It will be always. Cannot be in decimal or in float format. So 199, this is going 0 times, and 99 itself is a remainder here. So a small note, whenever any smaller number is in the numerator and a bigger number is in the denominator, and if you want to divide that, so your numerator itself is your answer as an reminder. Okay, this is the math part. Now here I'm going to apply the same math here. 7 modulus 3. I hope this is now easy to calculate. 7 modulus 3, because I have written I want to store this all data in 3 bucket. That's up to me. Okay, 3 bucket, 5 bucket, 2 bucket, 10 bucket. I can plug and play on this bucket size. 7 mod 3, 10 mod 3, 11 mod 3, 15 mod 3, 17 mod 3, 19 mod 3, 24 mod 3. How many is a remainder? We'll first write down only the remainder. Now, if I divide 7 by 3, remainder is 1. 3 into 6, 7 minus 6, 1 is remainder. If I divide 10 by 3, 1 is the remainder. 3 goes 3 times 10 minus 9, remainder is 1. Same math I'm using. 3 divides 11, 3 into 3, 9, 11 minus 9, 2. This is completely divisible. This is completely divisible. 3 into 5 is 15, 15 minus 15, 0. So 0 is a remainder. Then 17 mod 3, 3 goes 5 times, 5 into 3, 15, 17 minus 15, 2 is a remainder. Here 1 is a remainder. Here completely divisible, 0. Now my bucket 1 will have customer number. My bucket will have customer number. This data, let me change the color. This data is reminder 0 and reminder 0. So whatever customer number we have there will go to your bucket number 1, right? I'm just ordering this now. 0 will go to bucket number 1. This will go to, let me write here, bucket 1, bucket 1. This will go to bucket 2, bucket 2. This will also go to bucket 2. This is for bucket 3. And this is for bucket 3, right? So 15 and 24 will store in your bucket number 1. 15 and 24. Then bucket 2. 10, 10, 7, 10. And we have one more, 19. So 7, 10, 19 will go to bucket 2. And third, bucket reminder 2 is we have 11 and 11 and 2 and 2, 17. So 2 and 17, sorry, 11 and 17 will go to 11 and 17 will go to last bucket. I hope this math is clear. It's a very transparent, okay, simple. You have to say fx mod 3, divide the value, whatever is value. I'll prove this, okay. I'll go to my Hive and I'll run this query, but you will not see this, what logic I'm telling you, this won't be clear in the query part, because I'm just running a query. This is all happening internally by the algorithm of bucket. So we cannot see, but yeah, if you know this algorithm and somebody asks you, can you please write this data in number of buckets? So this you are deciding. Who will decide this number of bucket? So you will first try and test the total data, how many buckets they are distributing. If they're able to balance the total number, then you will apply this concept of bucketing. So total number is 7 here, and this is how my data is distributed. Let's take this example practical. Then we'll go to the use case where we'll apply on real-time scenario. I'll create first file. I'll create, say, a file with some employee data. RT. Cat modulus emp.txt. Employee ID 1, employee name, employee salary. Employee name, employee ID, employee name. I have this result available. I'm taking some sample 10 records. Okay. emp.txt. That's the data, and I want to perform uh, bucketing on first column, which is employee ID. So first I will create a table, create table, and table name is emp gov emp government employee. ID, integer, name, string, salary, double. Now earlier what I was doing when I was creating a partition column, so partition column was not a part of this table structure. Okay, we are separately writing that partitioned by and then column name, and partition column is always the last column of your table. If you check the structure, enter here. Bucketing, first you will define in your main table structure, then you will say clustered by, then you will say clustered by, and column name you have got apply on ID, which is type. No need to type the right because this type is already given. You just have to define the column name. Into as many number of bucket as you want. Let's say this time you want 4 bucket, so I'll say into 4 buckets. Enter. Row format delimited, fields dominated by, stored as, will keep by default text file. Now we'll write the data. We write the data from this file, to a new file. Now you cannot directly load the data to bucketing table. Okay, remember this point. You cannot directly load. You cannot run a load query here. So first you'll have to load that data to non-partitioned or non-bucketed table. So create one more table. Create table. You can say government employee dummy. I'll keep data first in this table. It is the name, string, then salary double, row format delimited, fields dominated by, comma. That's it. Load the data now here. Load data, local in path. What is the file name? In file path. Home cloudera emp.txt. Home cloudera emp.txt into table name. And what is the table name? Gov emp underscore dummy. Check the result first here. Select the star from table name. Gov underscore emp underscore dummy. So we have null data. The reason is I have given their comma separation and this is my tab separation. So a quick change in file required emp.txt let me make this comma separated. Now, when you reload this data, so you'll have to use override keyword, and rest of the query I will take care. Override into table then. Now we have got the data. Now to perform bucketing operation, you will have to again run one operation here. Set I dot enforce dot bucketing. Check this value. By default this is false. So if I try to do bucket, it will not work, and that is the reason I will set this to true, and then run a query. Insert override table gov underscore emp. I hope that's my table name, gov e capital emp. This won't change anything because Hive is insensitive. So gov underscore emp, select what all the column you want to take. A dot id is alias a dot name and a dot salary. From table this, copy from here and paste it. Enter. I will wait for this output. Yes, one more thing. The number of bucket you define, the number of reducer will start. Okay, the more number of bucket you give. So currently this they will generate 4 reducer because I have given 4 number of bucket. Why that is happening? Because your system is separating the input in different file system. So all are referred as a different key. That is the reason it will generate 4 reducer, 1 mapper. You can see it here. So the number of bucket is equal to number of reducer. Because of the physical file differentiation they are doing in HDFS side. So you're seeing this 17%, 58%. This is what is your data spilling. This many data is writing to HDFS. So data spillover. The data is written. If I check records in this, select the start from GOE EMP. I should have a data, but I cannot differentiate here. If you're checking the record order, right? If after checking the record order, you'll easily understand the bucketing has been performed already on this. But more clear, here also I can explain you. I'll come to this part later. Let me go back to HDFS first. SDFS DFS -ls user hive warehouse / db name, which is 12pm.db / file name gov _emp / 4 buckets we'll see. One second. Oh, sorry, it's a small folder gem. 4 bucket is there. I'll check the first bucket. And this is their by default API, which are creating these files 0, 0, 0. How many times? We have 6 times 0 into 0 _ 0 and cat. I'll read the result for you. Now, if I see my data here, okay, 8495, 110,627. How many number of bucket I said to my table? 4 buckets, right? So 4 buckets. While creating the table, in declaration I said this. Then internally, this is my column where I'm applying bucket. This is the column ID. And this is my bucket column. Now, this is what is fx. This time fx modulus 4. This column data is going to fx and dividing this data by modulus 4. So 8 modulus 4. How much is a reminder? 4 divides 8. This is completely divisible. There is no reminder. 4 into 2 is 8. So 0. Okay, again, use this. Please, people who are confusing. 4, 2, 4, 2, 8. 8, 8 minus 0. This is quatinent. I don't have to do anything with this. I'm interested to know this part. And same thing I'm doing. The same logic I'll be applying on other data set also. 4 modulus 4 is 0. Then 9 modulus 4, reminder 1. 5 modulus 4, reminder 1. 1 modulus 4. One second, 5. After 5, we have 1. So here we have 1. Then 10 modulus 4. Here we have reminder 2. 6 modulus 4, 2. 2 modulus 4, 2. 7 modulus 4, 3. 3 modulus 4 is 3. So without seeing the data in HDFS, I can tell you in first bucket, this 2 row is going. In first bucket, this 2 row is going. So let me write it here. First bucket, this is bucket 1. This is bucket 1. Because of their reminder is 0. Then bucket 1 will have this result. Bucket 1. So I'll write here bucket 1, bucket 1, bucket 2, bucket 2. This is also bucket 2. So bucket 2 will have 3 results. Bucket 2 has 2 row. Bucket 2 has 3 row. Bucket 3 has total 1, 2, 3, 3 row. And bucket 4 has 2 row. So if I add this total, this is 10. I'll verify it from my SDFS folder. I'll read all this first. Cat. I'll use a star here, and I'll use here hyphen R. I cannot read it, looks like. So I'll give directly this. This is in first bucket. This is in second bucket. This is in third bucket. This is in last bucket. So you can check this. You can do this practice. You can check one by one also. You'll see the same number which I'm telling you. Now, bucketing is done. We know the concept. Where we'll be applying this? Bucketing is mainly useful for joining. Any types of joining. Inner join, then left outer join, right outer join. If I'm applying on the same bucketed column, okay, I have to be careful here when I'm using bucket that do I apply this joining on the same column or is it a different column? Right outer join, then full outer join. You can do even here a semi join also, and some more. If I write, this is not there in, this is there in RDBMS SQL. So people who already work with SQL, they know. This I'm writing new joining, which is only available in Hive. Map side join. We're going to see all one by one. What is the use of map side join? Then bucket map join. Then sort map bucket join. Oftentimes this is known as a SMB join. Sort map bucket join. For specific cases only we'll use this. These are the optimization joining concept. Optimization joining concept. The query question, this is FAQ. People ask most of the question from certification side or in interview from this joining, because this is known to everybody, all knows what is this joining. I'll start with the inner join, then as we go forward we'll see this other join also. Now in optimization part you are 30% done. You know bucketing, you know partitioning. So in nutshell I can say partitioning can be applied separately, bucketing can be applied separately. Okay, you can apply both together also. If it is an integer, it is using number. If bucketing you're doing on the column, which is integer column, this is the integer column. So it is using the concept of 7 divided by this. What if this is a string column? Suppose I'm applying any bucket on the column which is a state, because this state has a type of a string, right? So if I apply bucket on this, I said clustered by state. So my syntax is as follows: clustered by state. And since I have huge records available, I'll distribute this in 8 buckets. 8 buckets. Now when they're a string, they're not using a simple math, they're using the lexicographical order. The order which we follow for any string is a lexicographical. We use such concept in data science a lot, in machine learning. Lexicographical orders. Now, what is a lexicographical order? It follows ASCII. It follows ASCII. ASCII has a separate number 0 to 65535. depends on what encoding style you're using, UTF-8, UNI, or any other encoding characters. So these are all internal math, internal logic is. At front, you see just few queries and you see the job is done. But important concept is always what is happening in the background. I'm going to see few query of joining, then we're good for today. Joining, I'll start from here. I'll create one table, and just to save time, we know now how to write table query. I'll copy and paste there. So I'm creating one table with the name customer. Row format delimited. Whenever you are doing this, I'll not recommend by the way, but if you're doing copy and paste, always do check this special character because the encoding style is different. If you have one single quote in Windows and you copy the same single quote in Ubuntu or CentOS, it will be represented differently here. So double check them. Now I'm loading this data from my desktop. Load data local in path /home /cloudera /desktop /cust. I'll just verify. CUSTS into table. Data is loaded and we'll validate the select a star from table name limit 10. We have result stored there. Now second table, how to create with out1. Then row format delimited. By fields delimited by semicolon. This is created. Now I will join two table and get the common result from this two table. Okay, so check this query. I'm joining on table TXN records. I'm joining on table TXN records and I'm joining on table customer. So can I say this is table A, this is table B, and this join is inner join? What do we know about inner join by the way? So inner join will only collect those data which are common in table 1 and table 2. Table 1 is customer, table 2 is TXN records. Okay, so it will run a query on this two table, and this table has many columns. So which common data? Common data from the column cust number, right? Common data on the column cust number. So this cust number must be present in this table also, which is customer, and this customer should be present in this TXN records also. Then whatever result is common. Suppose here I have 1, 3, 5. Here I have 1, 7, 5. So 1 is common, 1 and 5 is common in both. So this row will be extracted and stored in this table out1. So that's about your inner join. Let's do that. Since I have my TXN records table and customer table both available, I will try to get few data from table number 1 and few data from table number 2 and store in out1. Query is there. Insert override table out1. In the same line. Select a dot customer number. We already know this query. This is new from customer, and then I'm extra writing, I guess, from there. This is the extra line. Join, from join it is started and goes there. Join records, takes and records B on A customer number, B customer number. So A and B is alias for table 1, table 2. From table 1, it is taking customer number. From table 2, it is taking customer number, and whatever customer number is matching, okay, it will bring that result here. Now, after this, I can check how many result we have common in this 2 table, and then we can get the data. So before that also, if you want to run, you can run this query and check how many total count is there. Run this. So this is a DRL query. Okay, I'm not inserting currently. After I will check the total record number of row, and then I will upload it. So this is having some 49,995 records. Okay, which means my out one table will have this many results. I'll say insert overwrite table out one. That's it. And enter the query again. You can see total number of rows inserted for 49,995, and I can check with this. The total row which I extracted was the same. Total data which I've inserted to the table out one is the same. So this is reconciliation part. After that, second query. I'll create one more table, and Hive provides switch case, so we're talking about the switch case also. Creating one more table out too, and I'm creating one column here as level string. So this is having the exact number of column. Okay, if I size this, yeah. If you could see my out one table and out two table, right? Both have a same number of column. Out two has just one extra column. So out one, I have customer number. First name, age, age, profession, profession, amount, amount, product, product. I'm keeping one new column, level column, because I want to run one switch case. So the switch case is also allowed in Hive. Switch case means you want to refer, like if somebody is having age less than 18, you say the guy is teen, right? Then if somebody is having age, uh, I'm sorry, this is opposite. If age is less than 18 is teen. Then age is more than 18, or you can say in between, like you can give a end operator. And if age is less than 30, if age is less than 30, you say the guy is young. If age is more than 30 or equal to, and age is less than 50, you say the guy is middle. Likewise, you can create a case, right? Age, this is like an if else condition. Age is more than equal to 50, and age is less than 60, that's the old guy. If age is more than equal to 60, less than age is 70, you say the person is senior citizen. Senior citizen. You can keep this to 90 also. Senior citizen. Right. So this is what? This is a case. You're creating one case. Same kind of case I want to create in Hive. And to store that new output, I'm creating one new column as level column. So query part, table creation part is easy. And query will see. Or two table is created. Okay, two more statement will pass. Row format delimited and fields terminated by semicolon, enter. So tables, if I do, I can see all the tables. Now from out1 table, this is my source table. From out1 table, I will insert data to output table. And I'm giving this conditions, right? If age is less than 30, it's low. If age is more than 30 and in between 50, it is middle, it is old. If none of the data is matching, then it's others, right? If data is not matching with anything, then this is others. Like a very simple if else condition. I'll write here insert override table out2. Here you want to store, select a star because you want to get all the column, comma, and then you are giving this cases. You write this keyword case when age is less than 30, it's low, or we can write young, let's say. Not low doesn't make sense. Then enter. Second, when age is in between this, the guy is middle, and when age is more than 50, the guy is old guy. If no match, then the person is others. End the query from out1. That's it. So it will create one new column, keep the data there. Good for sampling purpose again. We'll wait for the output. So this query does not take much time because this is a simple case. You're not running any aggregation. That's the reason number of reducer is 0. So when reducer is also there, your query takes more time. I'll run a query on select star from out to limit 10. You can see the last, old, middle, middle, old, old. Can you see only data which are young, where level is equal to young? Give this value. So many young, 7,050 result out of total 49,000 something. This is about out to. Switch case, two table joining, writing to third table, one more. And these are the multi-table insert. Okay, multi-table insert I will take separately. This yesterday we have run this query. Okay, so that's not I'm not repeating this. I had one table which is a big table, and from that big table I have only taken few columns on my one table which is out 3. So I perform that for txn. I perform that on txn part from txn records. So this is a big table, this is small table. So from this table we are writing some information on transactional part. Here they are writing, they are doing a query, aggregation query, and whatever output is coming on this query, they're writing this output to out3 with 2 different column, level and amount. Now how can we do joining? So I'll create 2 files first. This is the last query for today. Cat emp.txt. So emp is already there, and that's all I can say, emp1.txt. And we'll have this result. Tab or comma is there, so I'll keep comma. Some number and some location. Then some number, some location, comma. Should write as .00, that's okay, but Pune, Raju, comma, 21,000, comma, Mumbai, Mumbai, Hyderabad, Satish, 20,000. Okay. Control D, cat emp1.txt. So this is the comma separated data. I'll create one more column, cat email.txt. So in email, I have person name and their mail ID, email.txt. Person name, Sweta, comma, Sweta@yahoo.com. Then Tarun, I have new name, different name, Tarun, simply learn.com. Mayur, edureka.com. Ayush, comma, Ayush@coursera.com. And Anamika @Parvati.com. So this is mail ID and their name. get email.txt. Then we'll perform the joining on this two table. So first I will create the table and load this data. Create table my emp. We have employee name, which is a string. Salary I kept as integer, so I'm giving integer. Okay, let me try with double. If it takes by default .00, otherwise I need to reload it again, or I need to alter the table. Salary double, and location or city is string. Row format delimited, fields dominated by comma. Close. Load data local in path. Home Cloudera. We're creating this on home Cloudera desktop. So home Cloudera desktop emp1.txt into table name. Select a star from table name, which is my underscore emp. Data is there. Now second table, their name. I'm using my previous structure, name and mail ID. So name will remain same, and mail ID is string. Row format delimited, fields dominated by what happened? Already exists exception. Sorry, table name I did not change. My email, I should say. So tables, load data local in path, only file name will change. This is change and this is change. My email. What's the file name? Email.txt. Select a star from table name again. My underscore email. Data is there. Now let's run a joining, inner joining, outer joining, left joining, right joining, just a single query. Select what all the column you need from table number 1. So table 1 is having this result, table 2 also will write my emp. So I want to get their name and salary, name and mail ID. Okay, how to get their name and mail ID and salary. Select a dot name comma b dot salary comma b dot sorry, a dot mail ID is also required. A dot mail ID. Then from table 1, which is my underscore emp, which is table A, which is table B, my emp table B on inner on table 2, which is my underscore email A, join, or I think I'm doing opposite, join on should be join on a dot What is the column, common column? A dot name is equal to B dot name. So this will give me in total how many name is common. Sweta and Amanamika, just two name will get here. Number of reducer is 0, by the way, okay? And if you're able to guess this, why it is 0, because this is not aggregation query. Always remember, reducer will only call when there is a reducer aggregation query. This is two result, common result from both the table. Can I do left outer join? Left outer means all the record from first table and only few result from second table, as in common result from second table. So what is my first table? EMP is my first table. It will take all the employee name, but only mail ID of those employees who are which are available in table 1. Two more query, I think, then we are done for the day. This is done. Left, right, and full. Yeah. So there's two query. I'll set the agenda for next, and I'll give you some other thing, okay, which you can refer after this. This is total 4 result I'm getting because salary is present in table 1, which is my MP table, and salary is only present, but name and mail IDs is only present in 2 tables. So those are common coming, others are not coming. I'll change this a bit and say a dot name, a dot mail ID. Instead of calling this, I'll say this is A. However, this is B. This is also A. And this is mail ID. This is B. Now I'll use right outer. So all the result from table 2 and common result from table 1. So you can refer this right and left as left as table 1, and right as table 2. So this will simplify your question. Table 1, table 2. Yes, Martin, that is based on the data set. You can send me your application, yeah, sure. So this is the result of right table column name. So all the result we're getting for second table, which is my email. My email is coming for all. Then name we have just common name, salary also in common. Full will give me all from both the table, left and right. one reducer is there. We'll see why one reducer is there. Full outer join is giving me a complete result for A and B. Table 1 all the data, table B all the data. So total we have 1 2 3 4 5 6. Okay, now total, because this is the entry 1 2 3 4 5 6 7, 3 and 4 entries. We have 4 in one table, 3 in second table. So this is your basic operation of joining. Few things which we'll see on next class. Semi join I'll start. Semi join, map side join. There are few setting I need to do on my cell again for map side, bucket map, sort map. And just in short, if I tell you, if I refer this this joining concept, this is there in MapReduce, but MapReduce does not work with a table. MapReduce work with a file. And we had there discussed 3 point. Yeah, you can revise those videos. Distributed cache. There was one concept of distributed cache. Cache means keeping few amount of data in a RAM, right? So that data processing can be faster. Second was my map side join. There also I had, guys. You can see this in the tip, chapter number 7 of O'Reilly book. Map side join and reduce side join. But only problem that this whole concept I am applying there in MapReduce, but with file. With file. Here I am applying this concept on my table. Right. So this is the only difference. Here it is easy. Here it is programmatically. You'll have to write a program in Java, in Scala, in Python, and then deal with this file. And here it is just a query part. So few setting and then query wise, we'll see how we can optimize any operation from the reducer. For any reading purpose, if you want to read things, you can go to a Hive tutorial, and not a company Hive tutorial. You can definitely refer for few references, but official page of Hive will give you more information. So anytime if you want to build your concept, always go with this. There must be some. I got a good point. Let me see that. Where is Hive wiki? So if I click on any topic, let's say I want to do, this is on mainly installation blocks. One second. This is not the one which I'm looking for. Apache Hive CWiki. Let me see that page. Okay, that's a good blog page for official purpose of hybriding. So joining will, other part of joining will start on Saturday.